To become airborne, an aeroplane needs to be as light as possible. It's made from aluminium. The coachwork of this train doesn't need to be painted. It's also made from aluminium. Here's another use for aluminium: the cylinder block of this engine. These wires will be used to conduct electricity. They're also made from aluminium. Engineers use one material to make many different things, but they also make the same thing out of many different materials. This gear is made of cast iron, and this one's made of steel. And from steel gears to one made of a totally different material, Tufnol. Gears can be made from brass like the ones in this box, or cast bronze, or even from a plastics material. So, on the one hand, one material can be put to a great variety of uses, while on the other hand, a wide variety of materials can be used to make similar components. Materials are chosen for the ways they behave. The material for the blade in this saw has been chosen because it can be used to cut metals. The fact that this material will behave in this particular way is a property of the material. A property is the way a material behaves. A car body must be made of a material that is strong. Steel is one such material. It also has another useful property. It can be spot welded together, which is a quick and easy way of joining the parts. Properties are just as important in manufacture as in service. This is a plastics material in the form of thousands of tiny granules. This material has the property that at a suitable temperature it will melt. It can then be automatically injected into a suitably shaped mold to form a gear. This is a relatively quick and easy way of making a gear. But as a rule, plastics materials don't possess the property of strength. If we need that, we need to use a material like steel. But steel can't be molded into this kind of shape, and so the teeth have to be cut, more or less one by one. So to gain strength, we've lost the property of moldability. This often happens in engineering. This car ferry is coming into harbour. In order to pull her into her berth and hold her there, steel cables are used. These cables need to be strong. The property of being able to withstand pulling or tensile forces is tensile strength. Tensile strength is also required in lifting gear, such as the cables on this crane. These cables are often made from high tensile steel. But look at those piston rods. They're pushing up against the weight of the jib, so they're being compressed. A material which will withstand pushing or compressive forces has the property of compressive strength. Piston rods such as these usually have to have both tensile and compressive strength. They may well be both pulled and pushed. Now, a manufacturing process. These are copper rods, and this is a specially shaped die. We'll take a copper rod and reduce the diameter of one end. We do this so that we can get that end through the die. The end is caught in a clamp. The clamp is so arranged that the wire can be pulled through the die and round the capstan. Watch. Now let's see what's happened to the rod. It's become longer. It's been drawn out. A material that can be drawn out like this is said to be ductile. Ductile materials like aluminium are used to make wire. Aluminium rod is taken from a drum. It's pulled through a die and round a capstan. Through another die and round another capstan. And so on. See how, as the aluminium goes through the machine, the capstans go faster and faster. They have to, because the material is getting longer all the time. Ductility is the property that enables a material to be elongated or drawn out into a wire. This plumber is going to make a corner in a sheet of lead, such as you might find in a box gutter in a roof. He does this by beating the lead with a special wooden hammer, usually called a dresser. The property which allows a material to be shaped by hammering or beating is malleability. The beating process pushes the excess lead up into a peak at the corner, where it is simply cut off. Many materials, including steel, are malleable only at high temperatures. This steel ingot is at a temperature of about 1200 degrees centigrade. And now to a totally different property. Toughness. This is the ability to withstand shock loading or impact. It's needed in many places on a railway, especially along the line where there are discontinuities. This is part of a set of points which takes a lot of shock loading when wheels go over it at speed. A property particularly needed by cutting tools is hardness. This is the ability to withstand indentation or abrasion. This machine tests for hardness by pressing a diamond into the surface of the material to be tested, in this case, mild steel. The relative hardness of a material can be measured by the size of the indentation. The smaller it is, the harder the material. This model of a ball bearing will show why hardness can be important in other components besides cutting tools. We'll stop the ball bearing and make an indentation in it. Imagine what would happen if there were such an indentation in a bearing like this one. Hardness is essential in all sorts of engineering components. And now a better known property. It's found in the suspension of motor vehicles. Without it, the ride would be even more uncomfortable than it seems to be here. If a material can be deformed and return of its own accord to its original dimensions when the deforming force is removed, we say it has elasticity. Springs are designed to exploit the elastic properties of the material they're made from. Here's another example of elastic behavior. Let's compare this with a ball made of another material. That was inelastic behavior. Now this is a porcelain assembly used in connection with overhead electric cables. It's being hoisted up to be attached to a pylon. This porcelain assembly doesn't conduct electricity. It's called an insulator. It's used to suspend the cables that do conduct electricity. The cables have the property of being able to conduct electricity. The insulators don't, which is why a current doesn't run to earth down the pylon. A similar thing happens when it comes to heat. This ladle doesn't melt when it's full of molten metal. That's because it's lined with a material that doesn't conduct heat. This is easier to see if you look in an empty ladle. In the properties of materials, non-conductivity is just as important as conductivity. Now, in a piece of engineering like a motor car, a great variety of materials is used. Each material has been chosen for its properties. Let's look inside the car and find out what some of the properties are. The cables and linkages are frequently pulled. They're stressed in tension. So they're made of a material which has good tensile strength, high tensile steel. The connecting rods are constantly being pushed down the cylinders. They're stressed in compression. They're made of a special steel which has been treated for strength. The body panels are made by pressing them out of sheet metal. So a material is needed that's both malleable and ductile. Here, mild steel is used. Can you think of another material which would do just as well? The crankshaft must be tough. In service, it's going constantly to be pushed and pulled around. It's made of another special steel. It's not hard to imagine what property the valve springs must have. They must be elastic. They're made of a fairly high carbon steel. The pistons must be sealed against oil and vapor. The seal is provided by piston rings. As these are going to be rubbing constantly against the cylinder walls, they must be hard and are made of cast iron. The cylinders also are made of cast iron. The radiator is there to cool the engine and is therefore made of a material that will conduct heat. It's largely made of copper. The cables in the electrical system must obviously conduct electricity. They're made of copper too. The cables must also be insulated from their surroundings, so they're covered with a material that does not conduct electricity. A car contains many other components that we haven't looked at. See if you can think what properties these other components must have.